I think no, I didn't.
All right, P.5b. P.5b. Sometimes it works, sometimes it doesn't. All right, we're gonna solve some more equations. So on Friday we solved quadratics, and today we're going to solve some polynomials, absolute values, and radicals. Okay, so 3 parts. I think I have 2 examples for each. Okay, here we go. Letter A. Let's start with some polynomials, and we're going to solve these on our calculator by graphing. Now, with graphing on our calculator, you do not have to show work. You don't have to draw a picture. All I need are answers. Okay, so yes, some of you guys are smiling. You like that. I guess so. All right, solve by graphing. And make sure that, you know how to graph on your calculator, I hope, by now. All right, letter A. Let's do 4x squared minus 20x plus 17 equals 0. Okay, here's a quadratic to solve. And you probably know how to solve this 4 different ways, maybe? Well, no, it's not. I don't know if it's factorable. It's not. We're going to solve it by graphing it on our calculator. So, yeah, this is what we're going to do. Go ahead and go to y equals. Okay, clear anything out. If your plots are turned on, make sure they're turned off. We're not doing scatter plot. And what we're going to do is we're going to put one side of the equation in for y1. So we're going to put 4x squared minus 20x. Make sure you use the minus symbol. Someone in my last class used the negative on accident and it made the graph look really weird. Plus 17. Okay, and then y2, I'm going to make that equal to the other side. And so what I'm doing is I'm just finding out where these 2 graphs are going to intersect. My answers will be the x values. Yeah, and then hit graph. If your graph's not a good window, hit zoom 6. It should be a polynomial, a quadratic, a parabola. And then there's also a line for your y equals 0. Now those of you who have a new calculator, you get 2, right? You get a blue and a red. That's pretty cool. I do not.
I get black and then some more.
Yeah, well, your calculator stinks. All right. So here's what we're going to do. We have 2 answers. They are right there and there on the x-axis. So we're going to go to second trace, which is calc. We're going to calculate their intersection, so number 5.
Wait, what do we click?
Second trace. So you can either push the number 5 or you can arrow down to it. And then this is where your calculator is going to ask you 3 questions. They're asking you if this is the first curve, y1 equals 4x squared, Yes, that is the first curve, hit enter. Then they ask you, is this the second curve, y2 equals 0? That's the second curve, yep, hit enter. And they're like, can we guess? Sure, you can guess. I'd like to be more accurate, but yeah, go ahead and guess. And hit enter one more time, and you get that x equals 1.09. Just rounded 2 decimal places, no work to be shown, so 1.09.
Wait, what did we click at calc?
What? Number 5. Intersect. Okay, now we need to find the other one. So we're going to do the whole thing all over again. Go to second trace, which is calc, number 5. But this one, you're going to need to move the arrow. You're going to need to move that blinking little guy over. So use the right arrow to go over to the other side. And you just need to be anywhere over there. You can be past it, as long as you're closer to that one. And then just quickly hit enter 3 times. You know what they're going to ask you. And you get 3.91. So rounded 2 decimal places. Do you remember doing this last year?
Yes.
Good. I know I have a couple of kids who never had used this calculator before because they're new to the school and struggle. It's sad. All right, let's try another one. Letter B. Let's do this one. I didn't do this one earlier. X squared minus 2x plus 6 equals 2x squared minus 6x minus 26. This is the one that we just did in our homework. We solved this one by factoring. I had to bring everything over and we factored it. We're going to solve this by graphing. There's 2 ways to do this problem. One is you can, plug this in for y1, plug that in for y2, and find their intersect. Or you can bring everybody over and set it equal to 0 and do it that way. It's really up to you. I think I'm just going to plug them in. y1 and y2. See what happens. I didn't do this one earlier, so I'm kind of excited about it. All right, so we have x squared. It's going to be two parabolas intersecting minus 2x plus 6. And if they do not intersect, then, of course, the answer would be no solutions, because sometimes they don't intersect. And then 2x squared minus 6x minus 26. Okay, and then I hit graph. Let's see what this looks like. Oh. Okay, so it's a big parabola and a little one. Did I do it wrong? Is that what yours looks like?
Yeah. Oh, no, yours is not anything like that.
Yours, okay.
Mine looks like that. But
So let's go ahead and we need to change the window.
Window.
We're going to change the window. I'm going to go, I don't know, negative 20 to 20.
Negative 32.
Okay. And then negative 20 to 20, I'm going to try that. Sometimes you need to adjust the window. And then I'll hit graph. Let's see if that worked at all. Oh, a little bit. Ooh, getting closer. 32, is that the key? Yeah, okay. So I'm going to change my window again. I'm going to, I'm going to go negative 40
Oh my goodness.
to 40.
It's going to be too big.
I know, but it's okay. It'll still work.
Negative.
But this is what I want to show you. Like, sometimes you have to adjust it. You have to be like, okay, what's it going to be? Oh, that didn't work. I need to change it. There we go. Now, that's pretty good.
What did I... Wait.
Oh, here we go. Go ahead and do the calculate thing. So second trace, number 5. Hit enter 3 times, and it should find one for you. It did. Ooh, it's a good one. We just did this one, right? It was what? Negative 4 and 8. Right? Okay, so x equals 4, or negative 4 is one of our answers. And then let's do it again. We're going to calculate the intersect. And this time,
32 was perfect.
Was
Oh
it?
My God. How did I know?
I don't know. This time we're going to go to the other side and hit enter 3 times, and it gives me x equals 8. See the y value? The y value is 54. That's way up there. But it didn't need it. It's like, I can't see it, but it still found the intersection. So those are your 2 answers. So just be aware that sometimes you do need to change your window. If I were to do this one again, I probably would have subtracted everything to the other side and just made it equal to 0. Yeah, Bobby shakes his head yes. Okay, let's move on. So that's solving by graphing. Good luck with those. All right, letter B. Good luck. Let's do some absolute value equations. Now, you did these in Algebra 2, like in the first chapter, so you may not remember them, but they're going to make them a little bit harder.
Oh.
So here we go, number 2. Let's start with an easy one, something like this. 2x minus 1, absolute value of 2x minus 1 equals 6. All right, so for this problem right here, we're going to get 2 answers, okay? Because this stuff inside of here can be 6. Like if I take the absolute value of 6, I get 6. But it could also be negative 6, right? So when you take the absolute value of negative 6, you also get 6. So we need to set up 2 equations. 2x minus 1 is 6, or 2x minus 1 is negative 6. So that stuff inside the absolute value could be 6 or negative 6 in order for it to work. Do you remember doing these at all? This was like first semester. This was a year ago. All right, so let's add 1. Divide by 2. So x is 7 halves, or 3.5, whatever you prefer. And over here, we're going to add 1 and divide by 2. X is negative 5 halves. All right, so you get 2 answers for these. Nice and easy. All right. Now, the next one we're going to do, these ones were in Algebra 2 also, but they were a little harder. They look like this. Absolute value of x plus 1 equals 2x minus 4. All right, with these are the ones that you could get extraneous solutions. Do you remember that word, extraneous solutions? You didn't do anything wrong. You did the problem right. It's just your answers don't work, some of them. Okay, so what we're going to do is this. We're going to set it up the same type of way. This stuff in the inside here can either be the positive of this stuff or the opposite of that stuff. Okay, so in other words, we're going to set it up as x plus 1 can equal 2x minus 4, or x plus 1 is the opposite of 2x minus 4, which would be perfect, negative 2x plus 4. Okay, and so now you have 2 equations to solve. So what I would do is I would probably subtract x and add 4. So I get x equals 5. And over here, I would probably add 2x. So I'd get 3x equals 3. So x would be 1. All right, now you need to check these to see if they work. Okay? The last ones I didn't need to check. There wasn't going to be a problem. The only problem is if I have an absolute value right here and it equals a negative number, that can never happen. Okay? So if I plug in 5 over to this side, I get 2 times 5 minus 4. If you want to do that in your head, that's great. You don't have to show that. And I get 6. Perfect. If I look over here, 6 equals 6. But if I plug 1 in over here, I get 2 times 1 minus 4, which is negative 2. That's not going to work. I cannot have an absolute value equal negative 2. Okay? So this one's extraneous. I want to see that you found it, and I want to see that you crossed it out. Graphically, what this looks like is it's an absolute value graph that's been shifted 1 to the right. Ooh, it should be on the x-axis. And then it's, it goes up pretty high. And then it intersects with the line, kind of like that, right there at 5, when x is 5. I didn't draw that very well at all. Okay. All right, now, number 4. I have one more of these. And this is the problem that you did not do in Algebra 2, but you're going to do it here. Here we go. Absolute value of x squared minus 3x equals negative 4x plus 6. All right. So for this problem, there's a squared inside of here. You haven't done that before. So let's go ahead and see what that looks like. You're going to set it up the same way. The stuff on the inside is going to equal the positive of that, and the stuff on the inside is going to equal the opposite. So here we go. We've got x squared minus 3x can equal negative 4x plus 6. Or x squared minus 3x equals 4x minus 6, the opposite. Okay, what makes this problem hard is it's an absolute value equation, but now we have to solve a quadratic. But we did that on Friday, so you're all set. So let's bring everybody over to the left-hand side. So we'll go x squared plus x minus 6 equals 0. And I like to make these factorable. Sometimes the book doesn't. You would have to use quadratic formula. But this is factorable. Two numbers that multiply to give me negative 6 add up to 1. Positive 3, negative 2. So I get negative 3 and positive 2. We still have to check those answers in just a minute. Let's go over here and solve this, and then we'll just check them all. So add 4x over, subtract 4x over. So you get x squared minus 7x plus 6 equals 0. And this is such an amazing problem that it actually factors again. Ooh, are you impressed? No, okay. And then what times what 6 adds up to negative 7 would be a negative 6 and a negative 1. And so I get 2 answers again. Now there's no way this is going to have 4 answers. Is there a way? I don't think so. So I need to check them all. Now that's a lot of work, right? You're like, ugh, that's terrible. Just check. No, don't give up. Just check this. Just plug them into this side to see if they're positive or negative, okay? So if I plug in a negative 3 over here, I will get a positive, so negative 3 works. If I plug a 2 over here, I'm going to get a negative, so that one, no. 6 goes over here, you're going to get a negative when you plug 6 in, and then when you plug in 1, you'll get a positive. That's a nice, easy way just to quickly check to see which ones are good and which ones are bad. And it works. It works. Okay, last part, part C. So we did some graphicals, A, B, C. We did absolute value. Now we're going to do some radicals. I heard a groan. What's wrong with radicals? They're good. I do too. They're radical. Number 5. Hey, Ben, did you see that balk off this weekend? The Dodger game? Anyone watch that game? Bases were loaded, and the guy balked, and they won? Ridiculous, huh? No one cares about the Dodgers? Oh, okay. I cared because I don't even know what a balk is. I was like, what just happened? All right, here we go. It's like something about a pitcher, the way they step off the mound with the, I don't know. It's really the dumbest rule in any sport. Yeah. Stop. And then he walked off. Yeah. And then that won the game. That was in like the 10th inning or something. It was ridiculous.
get you to
I talked to Mr. Brass about that today. Okay, here we go. Oh, I like this problem. You know why? Because I want you not to solve it. I want you to just stand back and look at it and try and think what the answer would be.
6.
No.
7.
Oh, don't guess.
But that's
Like
how
educated guess.
Oh, educated.
23.
Oh, I was actually just gonna guess 23. No.
Can you do that though?
No, you don't.
Like I'm terrible at that. I'm terrible at looking at it and going, what's the answer? I'm a solver. I got to show my steps and my work.
Same.
Yes, and that's okay. But I kind of like that. Like if you can stand back and go, that's got to be 5 plus 10, so that's got to be 25. Oh, it's 23, right? Okay, but let's go ahead. Let's solve it. Subtract 10. Let's solve it the old-fashioned way. Rad x plus 2 equals 5. And then we have a radical here, so we got to square both sides. Equals 25, so x is 23.
Yeah, I can't do that.
Me neither.
I can, I just prefer to show my steps.
Yeah, I love that someone can look at that and be like, 23.
If I feel like if I did get my head, I would miss a step.
Yes, I never trust myself on that. Okay, last one, number 6. In real life? No. Why would you do that? All right, here we go. Square root of x minus 3.
Kyle told me he's gonna be doing simple math. He's for the rest of the class.
Good. Simple math, yeah. My sister, she'll call me sometimes, ask me to help her with some algebra stuff at her work. She does. Set up an equation, I solve it for her. All right.
I solved for it. She gets paid for it, but I don't.
Yeah, she makes a lot of money. All right, let's go ahead and subtract 5. Oh, probably twice what I
More
do.
than you.
Twice?
Does she make?
All right, subtract 5 over to the other side. Probably twice what I make.
What does
With
she
bonuses. She's a general manager for Best Buy.
That's fine.
She works in a warehouse. Geek Squad.
Does she
All right.
really?
Yeah.
Squad?
She's in charge of like 100 people.
Does she like
No.
Is she good with technology?
No. She's good with people. She's a manager. She doesn't have to know technology. They do. All right, let's go ahead and square everything. And, ooh, this problem makes it a little bit hard because what's going to happen is...
What did she go to college for?
Shush! You're going to... We're going to FOIL this out. This x minus 5. I know. You want to write x squared plus 25. That's really wrong. Yes. X squared minus 10x plus 25. Did you do that in your head?
I just remembered
The pattern, right? There's a little pattern here. It's always you square the first one, and then you multiply everything that you see, x times negative 5 times 2, and then you square the other one. Yeah, you double it. Okay, so now I have a quadratic to solve, again. So let's go ahead and subtract x and add 3. Anytime you see that squared, you have to solve it by factoring or quadratic formula. Why did I write that? X squared, add the 3 over, so minus 7x. And then, whoa, no.
I don't have an eraser. You can't do these things.
Minus 11x plus 28. Okay. So funny, I've already done this problem today. And I just messed up on it. You don't get that part?
Oh, no, I did. Okay, that's okay.
Are you sure? No. I subtracted x over and got negative 11x, and I added 3 and got 28.
Oh.
I brought everything over to one side. Okay. All right, now let's factor, because you know what? I know, I love factoring. I usually set them up on a quiz or test. Next Tuesday is your test on this stuff.
It was like one.
Test.
Test on it.
Not quiz?
No quiz.
Last year, a lot of people got D's and F's, correct?
On this test, yeah.
What?
So you get 7 and
So
4.
don't expect much from it.
Oh, dang. All right, let's, for these, you have to check for extraneous solutions on these too. Okay? So if you plug in 7, you'll get 2 plus 5 is 7, perfect. But if you plug in 4, you get 1 plus 5 equals 4. So there's an extraneous solution right there. X equals 7 is the only answer. Yeah, so if you go up here to x minus 5 squared, you can, if you want to, FOIL it out like this. Because x minus 5 squared is just x minus 5 times x minus 5. And then you FOIL in first, inside, outside, last. But if you wanted to, there's like a little shortcut that if you have anything a binomial squared, you take the first term and you square it. And then you take these together, negative 5x, and you double it. Because see, when you do this, you get 2 of them. You get negative 5x and negative 5x. So you take x and negative 5, and you double it. So you get negative 10x for your middle term, because you do it twice when you FOIL, and then you get negative 5 times negative 5 is 25. So that's just FOILing a binomial. Yeah?
Where did you put the errors to check on
Oh, tip-toppy, very original problem right here. If you plug it in anywhere else, they'll work, but you have to go to the original problem. The original, yeah.